Let's do a couple extra practice here because percent change is tricky. So a little bit of extra practice can always be helpful. So we're going to find a 25% decrease of 140. And remembering that there are two strategies, so we're going to do both strategies for this problem. The first strategy is we want to do 25% of 140. So I'm going to do 140 times my 25% right away. And once we find this, this should be a 2, sorry. Once we find this, we are then going to subtract 35 from our original number. So 140 minus 35 is 105. So 105 is a 25% decrease of 140. Now, the other strategy is we kind of try to skip this step by thinking about if we start at 100% and we decrease by 25%, what is left? Well, what's left is 75% of the original number. Therefore, we will do 140 times 75%, and it should give us our answer down here on the bottom. 28, so 9, and there it looks like it's going to work out just fine. So once again, 105 is a 25% decrease of 140. And these are both algorithms. They will give you the same answer both ways. Now we need to find a 30% increase from 250. Once again, I'm going to show you both algorithms, but for increase, usually people stick to the two-step one, but we will figure it out from there. Okay, I'm going to erase this stuff over here just to give us a little bit more room. So 30% increase of 250 means that we need to find 30% of 250. Now, because this is a multiple of 10, I'm going to use my favorite strategy, which 10% is 25. So 30% has to be 75 because it's 3 times bigger than 10%, and 10% is just 1/10 of our starting number. Since we have 75 as our increase, we need to add this back to our original number. And if you noticed in the last video, we did mostly decrease. Well, that's because it is far more likely for you to get percent decrease because of sales in real-world problems at your age. But percent increase is just as common. Now, there is one part to the algorithm on the right that is trickier with increase. So normally, you start with your 100% and you go down a certain percentage and you see what's left. The problem here is that this time we are going up 30% from our 100%, which means now we will be 130% of the original. Therefore, if I do 250 times 130%, that will give me the answer this time. And as you notice right here, this is already going to be more difficult than what we have been doing in the past. So 0, 15, 7. But if you notice, we will still get the same answer of 325. So here is both algorithms for finding percent change when you're given the percentage. But what if we're not given the percentage and we want to find the percent change? Well, the two keywords are change over original. Once you make a fraction, you turn that fraction into a percent and you are golden. So for this problem, from 200 to 130 means 200 is our original number. 200 to 130 is a change of 70. 70 divided by 200 is our fraction, which if we divide both numbers by 2 gives us 35 over 100, which is 35%, and we are done. Let's do one that's a little bit tougher. From 120 to 240 means from 240, subtracting 120 is 120, which means we have 120 over 120 as our fraction. And 120 is all of 120, so that means we have 100% increase for this problem. Well, if you notice, from here to here is just doubling, so a 100% increase is just doubling. A 200% increase would be tripling, a 300% increase would be quadrupling, and so on and so forth forever. And now our last example is from 80 to 120. So 80 is our original. 200 is our new number. So 80 to 200 is 120 for the change. And 80 is our denominator for our original. And I notice immediately that our numerator is bigger than our denominator. Therefore, this is going to be over 100%. Since it's going to be over 100%, I'm going to make this into a mixed number. So 1 whole and 40 80ths left over. 40 80ths simplifies to 1 1/2. A half is 50%, so 1 1/2 is 150%. So percent change is not easy, but with practice, this is a skill that we can definitely master, and we can use it in a lot of real-world situations. As always, if you have any questions, please let me know.